Let's discuss the IUPAC nomenclature of alkanes. Previously, we came up with a number of steps that we can follow to write the name of any organic compound. Now let's see which of these steps are applicable in the case of alkanes. Step number 1 was to identify the functional group in the compound. For alkanes, there is no functional group present, so this step is not required. Then, in step number 2, we look for carbon-carbon double bonds or carbon-carbon triple bonds. Again, in the case of alkanes, there are no carbon-carbon double bonds or triple bonds. So this step is also not required. So when naming alkanes, we start with the third step, which is by identifying the parent chain of the compound. Once you identify the parent chain, then the next step is to find the substituents. Interestingly, for the case of alkanes, the substituents are going to be only the alkyl groups. Alright, so let's see some examples now and write some names for alkanes. Let's look at some examples. The first one is an unbranched alkane. In the case of unbranched alkane, there is only one chain, which is the parent chain. For example, in this compound, you can see there is only one straight chain. How many carbon atoms are present here? You can count 1, 2, 3, 4. So, you can write the name as butane. Very simple. Okay. Can you write the name of this compound on the right? We will first look at the parent chain, which is this, and it has 5 carbon atoms. So this will be pentane. Let's move on to the next case, which is a branched alkane, and it has only one substituent here. What is the parent chain here? Now if you look carefully and move from left to right, then you have a chain of 4 carbon atoms. Whenever there is branching, there is a possibility of more than one parent chains. In this example, if you move from left and then go downwards, you will see that this chain also has 4 carbon atoms. So any one of these can be selected as the parent chain. Let's select the straight one as the parent chain. So now the other alkyl group that is attached to this chain becomes the substituent. So this is our substituent. Now when writing the name of this alkane, we will first number the parent chain. If you number from left to right, we have 4 carbon atoms, and the substituent is present at carbon atom number 3. But if you go from right to left, the substituent will be present at carbon atom number 2. So in such cases, we pick the lowest number for the substituent. It is also called lowest locant rule from location. Alright, so now let's write the name of this compound. Since the parent chain has 4 carbon atoms, so it's a butane, but the substituent is attached at the carbon number 2. So we will say 2, and substituent is a methyl group, so 2-methyl butane. Can you try to write the name of this compound? Pause the video and try to name it. Alright, let's see the parent chain first. We can take this straight chain as the parent chain and then start numbering. From left to right, the position is 2, and from right to left, the position is 4. So we will take the position as 2. Now there are 5 carbon atoms in the parent chain, so this is a pentane. And the methyl group is attached at position number 2, so it is 2-methyl pentane. Let's do one more example. Now in this example, you will see that if you take the straight chain, there will be 5 carbon atoms in the chain. But if you go instead this route, there will be 6 carbon atoms in the chain. So what will be our parent chain? The chain with 6 carbon atoms. So what we need to understand is that parent chain is not necessarily the straight chain. And when numbering the parent chain, we number from the ends of the parent chain. It is not always left to right or right to left, but from the ends of the parent chain. So in this example, we can number from this end or from this end. Let's start numbering. So from here it is 1, 2, 3, 4, 5, 6. So the position of the substituent in this case is at position number 3. And from the other end, if you go, then the substituent comes at position number 4. So we will take the lower number. And since there are 6 carbon atoms in the parent chain, so this is a hexane. And at the third carbon, there is a methyl group attached. So this is 3-methyl hexane. We now have multiple substituents present in the parent chain. For example, in this compound, you have this parent chain and there are 2 methyl groups present as the substituents. Okay, so how will you name this? Count the parent chain carbons. So 1, 2, 3, 4, 5. So going from the left to right, one methyl group is at position 2 and the other one is at position 3. If you go from right to left, then one of the methyl groups is at position number 3 and other is at position number 4. So we can have either 2, 3 or 3, 4. Now using the lowest locant rule, we will take the smaller numbers. Alright, now the parent chain has 5 carbon atoms, so this is a pentane. There are 2 substituents, but both of them are methyl groups, so we can write them together as dimethyl. Di means 2 methyl groups. And what are their positions? They are at carbon number 2 and carbon number 3 of the parent chain. So the name of the compound is 2,3-dimethyl pentane. Now try writing the name of this one. Okay, let's take a look. Identify the parent chain. So you can see that the parent chain is this. Now there are different types of groups attached to this parent chain. There are 2 methyl groups and there is 1 ethyl group. Okay. How will we write the name of this compound? Once again, number from the ends of the parent chain. So from here, 1, 2, 3, 4, 5, 6 and 7. So the positions of the groups are 2, 3 and 4. 4 is for the ethyl group and 2 and 3 are for the methyl group. If you number from the other end, you will get 4, 5 and 6. So we will take the lowest locants. Okay. So there is a methyl group at position number 2 and a methyl group at position number 3. So we can write for that 2,3-dimethyl. And there is an ethyl group at position 4, so we can write 4-ethyl. But when writing the name of the carbon compounds, if there are different substituents attached, we write the name alphabetically. Okay, so the name will be 4-ethyl, then 2,3-dimethyl, and there are 7 carbon atoms in the parent chain, so it's a heptane. That's the name of this compound. Okay, let's look at this example now. We have another branched alkane, but in this case, the substituent is something that is itself branched. What do I mean by this? It will become clear once we draw the parent chain. So this is the parent chain in this case with 7 carbon atoms, and thus this group here becomes a substituent. A methyl group is attached to this carbon atom. So how do we name these compounds? First, find the position of the substituent. So from left to right, the substituent will be at position number 4, and from right to left also, the position is at number 4. So this substituent is present at position number 4 of the parent chain. Now we put a bracket here for writing the name of the substituent, and then since the parent chain has 7 carbon atoms, so we write heptane. Now, how do you decide the name of this substituent? You number the substituents chain as well and give the carbon atom that is attached to the parent chain the number 1. So this carbon will be given the number 1, and then from here you can move either to the right or to the bottom. Both are of the same length. Let's go right. So this substituent has 2 carbon atoms in its chain and it has 1 methyl group attached at carbon number 1. So the name of this substituent will be 1-methyl because of this group, and it has 2 carbon atoms in its chain, so 1-methyl ethyl. So that is the name of this compound. Alright, let's look at this problem. Can you decide the parent chain here? Look carefully. The chain from this carbon till the end has 7 carbon atoms, and that is the longest chain possible in this structure. Therefore, that is the parent chain. Then we have 2 substituents which are methyl groups and another substituent here that is a substituted alkyl group. Okay. So how do we name this? First, number the parent chain. From left to right, we will go and we will get the position of the substituents as 2, 3 and 4. And from right to left, if we go, the positions will be 4, 5 and 6. So we pick the lowest locants. So 2 methyl groups are present. One is at carbon atom 2 and another is at carbon atom 3. So this is 2,3-dimethyl. Now this substituted group will need to be numbered. So as we discussed, give the carbon atom that is attached to the parent chain as carbon number 1. Now you can move in any direction. All lengths are same. So I'll take the right one. So it is a chain of 2 carbon atoms. with two substituents attached, and both of them are methyl groups which are attached at carbon number 1. So the name of this substituent itself is 1,1-dimethyl, and the length of this chain is 2, so ethyl. And this group is attached at carbon atom 4 of the parent chain. So this is 4,1,1-dimethyl ethyl. That is the name of this substituent here. So the complete name of this compound will be 4,1,1-dimethyl ethyl, then 2,3-dimethyl for these two methyl groups, and then heptane because the parent chain has 7 carbon atoms. Wow! So in this one we used a lot of rules to name this compound. So you revise it a couple of times and get the complete hang of it. I will see you in the next video.